Welcome to Flawless Mathematics. Yesterday I have already started a new chapter, that is function, and today I will discuss the kinds of function, right? The kinds of function, and our mool agenda is one function, right? So we have already knew about what is function, the criteria of function, the condition, okay, conditions of function. So I have already told that if f is a function from a to b is a function, then f associates all the elements of a of set a, all elements of set a to elements in set b, such that an element of set a is associated to a unique elements of set b. Okay, I already told you, and write the conditions in the board, right? So if you already watched it, then very good, but if you have already have not watched that video, so please go to the first part and see the part number 1, right? So there I have already told about conditions of a function, and then we have already knew about image and pre-image, okay, image and pre-image. So ये सब हमने कंप्लीट कर लिया. Okay, so now next move forward. So what is one function? Okay, so basically one function is a kinds of function, right? So one function, one function. Okay, one function, right? So definition, first of all you have to know what is the definition of one function. Then I will teach you some algorithms, some illustrations also. Okay, so definition, that is a function, a function that is f a to b. So this is read as f maps a to b. Okay, f maps a to b is said to be a one function, okay, a one function or an injection, okay, an injection if different elements, and what is elements of a and what is elements of b, I have already show you, okay, of a have different images. What is image? Different images in b, okay, different images in b, right? So there some terms should be noted, that is image, okay, and elements, and one function or an injection, okay, different elements. So I have already told what is images, what is elements, etc. Now how can we merge in one function, right? How can we merge one function? So basically there if a function that is f maps 1 cross 1 to b, okay, that is see, suppose assume that a is a set and elements with 1 2 3. So 1 2 3 all are elements of a, right? Now what is one function? So if we consider this, if maps a to b is 1 in mathematical expression, then a not equal to b, a not equal to b, that is f of a not equal to f of b for all a comma b belongs to a. That means if a and b are the elements of a set, then it is mandatory that if f of a is not equal to f of b, then a not equal to b, and vice versa. that is if A equals to B, basically it's f of A equals to f of B, then such that A equals to B for all A comma B belongs to A. Okay. Now let me illustrate you. So a function, you assume that a function which associated to each country in the world. Okay. Let me interest you. Okay. See, and you already know that every country has its own capital, right? So illustration number one, okay, illustration 1. So let's assume a function which associates to each country in the world, right? In the world, its capital is 1. Okay, what it means? Basically each country has its own capital. Okay, so because different countries have their different capitals, right? Are you getting my point? Have their different capitals. Okay, so if we assume a function which associates to each country in the world, its capital is 1 because different countries have different capitals, have their different capitals. Okay, so it's a 1 function. Basically it's very easy. So if one country, so it's 1 capital, okay, not more than 1 capital, and it's obviously that one country has its own capital. Okay, now illustration number 2. Right? So see here that okay, let me draw figure, right? So this is suppose A side and this is B, right? This is B, and this is A1 and A2, A3, A4, and here B1, B2, B3 and B4. Okay, so suppose here, okay, A1 maps B2, it's a function, okay, it's associated a function. So A1 maps A2, A2 maps B4, A3 maps B1 and A4 maps B3. Okay, let me draw another figure. So it's figure number 1, suppose, and let me draw another picture here. So see, this is also X, and it's assume Y, and here also I write X1, Y1, X2, Y2, X3, Y3. Now here x1 and x2 both are maps y1. Here the function is g, and x3 maps y3. Okay. Now this is the another figure. Now which one is 1 1? Okay, which figure is 1 1 function? Okay, I am asking you. So which one is 1 1 function? Okay, which one is 1 1 function? So your answer is figure number 1. Figure number 1 is 1 1 function. Why? Because if that maps A to B is 1 1 function, this is our answer, is 1 1 function, is 1 1 function. But this is G is not 1 1 function. Why? G that maps x to y is not 1 1 function. Now what is the reason behind it? Not 1 1 function, right? So the reason is, see here two distinct elements, that is x1 and x2, have the same image under function g. Okay, under function g, x1 and x2. Okay, these two distinct elements, that is x1 and x2, have the same image, but our definition, from our definition we already knew that if that is 1 1 function, that is mandatory that different elements of A have different images in B. Okay, see here, different images in B, but here two distinct point in G. So here two distinct point in G, that is x1, two distinct elements x1 and x2 maps images, create images y1 under G. So that's why G is not 1 1 function. G is not 1 1 function because two distinct elements, right? Two distinct elements, that is, what is the two distinct elements? x1 and x2 have the same images, under function fg, under function g. Okay, so I hope now you are getting my point, that what is 1 1 function. Okay, one more thing, one more illustration. Okay, first illustration, that is it's natural example, because we already knew that every country has its own capital. Now illustration 2, that is in figure. Now illustration 3. Okay, illustration 3. So illustration number 3. So what it says, that is, let two set, let A, I am repeating, let A, okay, let A 1 2 3 and 4, and B, that is 1 2 3 4 5 6, and A, if maps, if, that is, okay, if, so if maps A to B, be a function defined by, okay, be a function defined by equation f of x equals to x plus 2 for all x belongs to A. Okay, x belongs to A. So here let A and B to relation set. So here A, elements of A is 1 2 are 1 2 3 4 and elements of B are 1 2 3 4 5 and 6, and f maps A to B be a function defined by f of x equals to x plus 1 for all x belongs to A. Okay, now you have to find the pair that satisfy these these condition. Okay, this condition. So start now. F of x x plus 2, f of x x plus 2. Okay, so here f of x equals to x plus 2. Now for all x belongs to A, that is 1 2 3 4, elements are x equals to here 1 2 3 4. Okay, now f of x, that is here f maps A to B, that is f of B, that is f of B or f of A. Okay, sorry, x here A, so f of A, it belongs to B, equals to B, that belongs to in B set, images. Okay, images, because here we already know what is images. So let's start finding the images of given elements. Now if we consider x equals to 1, then f of B or f of A, that is 1 plus 2, that is 3. Now see, 3 is already belongs to capital B set, right? And if we, so 1 comma 3 is a pair. Okay, sorry, so the pair is first of all 1 comma 3. Okay, 1 comma 3. Now so we observe that f as a set of ordered pairs can be written as f equals to, okay, f equals to now this, so 1 comma 3. Then if we consider the second element, that is 2, so 2 plus 2, that is 4, 4 already exists, so 4. Now if you consider x as 3, so 3 plus 2 is 5, that's also exists in B. Now 4, so 4 plus 2 is 6, already exists in B. So these 4 ordered pairs, so we may written as that we observe that f as a set of ordered pairs can be written as f equals to 1 comma 3, 2 comma 4, 3 comma 5 and 4 comma 6. Okay, now here clearly that different elements in A have different images under function B. So f of x, this function is 1 1 function. So okay, let me draw a figure here. So here it's 1 A and B, and if f of x is x plus 2, x plus 2. Now here elements of A 1 2 3 and 4, and we already observed that each element creates one image under F. So 1 creates 3, now 2 is 4, 3 is 5 and 4 is 6. So it's a 1 1 1 1 function, 1 1 function. Okay, and another elements already exist, that is 1 comma 2. Okay, so this is 1 1 elements. I hope now you are getting my point that what is exactly 1 1 function, and I have already illustrated via 3 examples. And okay, now algorithm, our next step is algorithm. Okay, so algorithm, stop. Now algorithm, so first point, our first point here, that is okay, first point. So step 1 is take two arbitrary elements, take 2 arbitrary elements. Okay, take 2 arbitrary elements, that is say x comma y in domain of f. Okay, in domain of f, that is in under f, in region of f. Okay, so it's in domain of f. Now step 2. So step 2 is so our first step is take two arbitrary elements x comma y in domain of f. Now step 2 is put f of x equals to f of y. So we put x and y in function, in the given function. So put f of x equals to f of y. Now our step 3 is solve f of x equals to f of y. If it gives x equals to y only, then f maps A to B is always true, or from definition actually, so it's a 1-1 function, is a 1-1 function, otherwise not. Okay, so this is our algorithm basically. Okay, so and one more thing you have to note it, that let f maps A to B and let x y belongs to A and x equals to y, then x equals to y such that f of x equals to f of y is always true from the definition. Okay, but f of x equals to f of y such that x equals to y is true only when f is 1-1. Okay, let me write here. This is one note. Okay, this is one note. So if let f maps 1 to A to B and x comma y, it's also assumed belongs to A, then x equals to y such that f of x, or implies that f of x equals to f of y is always true, right? It's always true from the definition. Okay, I've already written the definition. So from the definition, but f of x equals to f of y such that x equals to y is true only when f is 1-1, right? F is 1-1. So one thing, if x equals to y such that f of x equals to f of y is always true, but if f of x equals to f of y such that x equals to y is true only when f is 1-1. Okay, so that's all for today, and I have completed 1-1 function, and next day I will discuss many 1 function. Okay, so up to this, take care, bye bye. And a special announcement for you that I have already started a math batch, paid batch. So if you want to join that batch, so you have to contact me in 7501489846 in this WhatsApp number. Okay, so up to this, take care and bye bye.